will show you there are several types of compound event. Okay. We have three types of compound event. Okay, number one, you can combine the event. Using, okay, the first one, union. If you still remember when last semester you study about set, okay, set of real number, you seen this, okay, union, intersection, okay. So first one, if we want to combine two event, we could use this union. Okay, maksudnya you tak boleh nak letak A, B alone macam tu. Okay, A, B. So kalau you nak combine ni jadi dalam satu probability, you need to combine this using, okay, number one, you can use union. Number two, you can use intersection. So what is union? The probability that either event A or event B will occur. So here, the keyword is or. For union. Hopefully you still remember this. Okay, the keyword for intersection, okay, the probability that both event A and B will occur. So the keyword is N. So if you want to combine A, B using union, okay, you should use or, A or B. So baru boleh combine dia jadi compound. Okay, A or B. A union B. Okay, that is number one. Number two, we have intersection, A and B. Okay, ataupun you guna symbol intersection, A intersect B. So that is number one and number two. Okay, number three. So number three is a conditional event or conditional probability. This is also an under compound event. Kenapa I kata dia compound event? Because this conditional also involve more than one variables. More than one event. Okay, kat mana kita nak jumpa conditional ni? Kalau kita tengok balik, subtopic yang kita nak belajar dalam chapter 4, okay, subtopic that we study in chapter 4, okay, the conditional part is on the next subtopic, which is conditional probability. Kita akan discuss hari ini juga conditional probability. Okay, for that conditional probability, we will discuss in detail in the next subtopic. Okay, in the next subtopic, conditional probability. So you must take note that conditional probability is actually a type of compound event. A type of compound event. Maksudnya probability tu yang kita nak cari tu involve more than one event. Okay, that is type number 3. Okay, probability that event A will occur given that event B has occurred. Ni nanti I bincang lah dekat 4.3. So kalau nak bincang sekarang pun mungkin you tak jelas kan. Okay, tak faham statement ni. So nanti bila kita masuk 4.3, we will discuss this in detail. But then for number 1 and number 2, I think it shouldn't be problem because you have the basic on union and intersection. So maybe I just can recap back what or how we illustrate union and intersection using Venn diagram. So macam mana kita nak lihat intersection dengan union ni dalam Venn diagram. Okay. So now I will show you how do we illustrate tadi first apa? Union. Okay, is a union. Okay, now, so number 1. So this is union. Okay. So we should involve two event, at least two event. Okay, now kita discuss two event dulu. So, and event, okay, let's say event A and B. A and B should be come from the same sample space. Dia mesti daripada sample space yang sama. Okay. So if we want to combine them using union, so you akan buat A, ni symbol union. So how do we put this in Venn diagram? Okay, so this is my Venn diagram. So overall, the rectangle represent the sample space. So event A, okay, event B. Okay, based on your previous knowledge learning about this union, where should I put the union part? A union B. Where is actually region representing A union B? Dah belajar ni. Kita nak apply dalam event je. Dulu you belajar guna real number kan? Union, set of real number. So now kita nak ambil set untuk event. So where should I lorekkan shade the region so that it representing A union B. Mana bahagi kawasannya? Kat mana?
Dekat tengah yang bertindan tu.
Dekat tengah yang bertindan, maksudnya yang kecil tengah-tengah ni. Okay, ni union Ni union. Bukan intersection. Kita ada yang kedua nanti. We have number 2, intersection. Okay. Fadli, nak tukar jawapan tak? Kalau intersection. Okay. So
A dan B.
Haris. Okay, Haris kata tadi semua. Semua mana tu? Spesifik sikit. Semua maksudnya termasuk kotak.
A dan B.
A dan B semua. Okay, ni baru betul. So kalau yang first idea tadi, dia kata dekat tengah-tengah, so tak berapa tepat lah. Okay, kalau kita nak guna union, maksudnya or. A or B, okay, meaning we consider all. Okay, maksudnya yang luar tak payahlah. Okay, tak apa, nanti saya allow mereka masuk. Thank you. Okay, that one is for union. Okay, how about intersection? Okay, intersection sama juga case dia. Kita akan consider, so we will consider Venn diagram. Okay, representing sample space. We have event A, we have event B. Okay, event A, event B. So intersection meaning N. So N maksudnya mesti ada similarity. So kat mana ada similarity? Tu yang tadi tu. Dekat tengah-tengah yang ada bertindan dia kata. Okay, yang ada similarity ataupun ada karakteristik yang sama. Dia share same characteristic. So this is how we represent union and intersection. So maksudnya kita nak combine two event, you should use either union or intersection. Ada lagi tu sebenarnya, conditional. Tapi conditional kita bincang dalam 4.3. Kita tak bincang sekarang. Okay. Okay, so that's it about compound event. So nanti kita akan bincang lebih detail lah conditional dalam 4.3. Okay, next is mutually exclusive event. This is also important for today's class. Okay, mutually exclusive event. You should understand what is, if we say that mutually exclusive events, maksudnya dia mesti involve more than one event. Okay, kalau single event like event A, so event A saja, dia tak ada, it's nothing to discuss about mutually exclusive. Mutually exclusive event, at least you kena ada dua. Event A and B. So A and B are mutually exclusive. Bila? When? Okay, ni dia punya keadaan. Okay. So events defined in such a way that the occurrence of one event preclude or exclude the occurrence of any of the other event. Or in short, they want to say that mutually exclusive event is event that cannot occur together. Or I mudahkan lagi statement ni, nak lagi mudah faham, event with no intersection. Kan tadi dia melibatkan lebih daripada satu event kan. So if there is no intersection between them, so we call that group of event are mutually exclusive. Mutually exclusive. So we can represent mutually exclusive like this in the Venn diagram. So let's say I have a sample space. So I have event A and B from the sample space, and I would say that A, B are mutually exclusive if they are like this. Separate completely. Maksudnya dia tak ada bertindih langsung. So this is event A, event B. There's no similarity. There's no intersection. So this kind of events, we call it as a mutually exclusive event. Okay, kalau dia dah bercantum, lepas tu ada titik bertindih, ada bertindan tadi tu, that is not mutually exclusive. Mutually exclusive must be no intersection. Okay. So read these two statements. Complementary event are also mutually exclusive. So what is complementary event? We discussed about complementary event last week. Okay, remember if we have event A, the complement for A from the same set is A bar. So that is a complementary event. A dengan A bar, so actually they are complementary event. Melengkapi antara satu sama lain. Okay, so first statement tadi dia kata, sorry dia tengah loading pula. Okay, complementary event are mutually exclusive. Okay, nanti after this I'll show you example. Okay, to represent that statement. complementary event always mutually exclusive. But not the other way. Kalau you baca nanti second statement dia kata mutually exclusive event are not necessarily complementary event. So dia tak kata okay kalau dia complementary confirm mutually. Tapi you tak boleh kata mutually confirm complementary. Sebab tu dia kata are not necessarily. Ada case di mana mutually exclusive are not complementary. Okay, to understand more about this, I'm using two example to represent number 1 and number 2. Okay. Okay, number 1. So number 1, it says that complementary event ataupun always complementary events are mutually complementary events are also mutually exclusive. So once it's a complementary event, confirm it is a mutually exclusive. So example that I can share with you, let's say I do experiment, I roll a die once, maksudnya saya ada satu dadu, saya baling dadu tu sekali je. And I want to observe the number. I want to observe the number appear. Okay, so now the sample space that I have from that experiment is number 1, 2, 3, 4, 5, 6. So this is my sample space. So now I want to create event from the sample space. So I create event. The number appear is even number. So from the set, from the sample space, can you list all the outcome that refer to event A?
Dua, empat, enam.
Okay, 2, 4, 6. Okay. Every event has a complement ataupun every event has a complement has a complementary. So what will be the complementary for A bar? From the set 1,
3, 5.
1, 3, 5. Okay, so this A and A bar are complementary event. So now I want to check, is this complementary event mutually exclusive or not? So based on your understanding with the previous slide, what do you think about this complementary? Is this mutually exclusive or not?
Mutually exclusive.
Mutually exclusive. Yes. The reason why we say that this is mutually exclusive because there is no intersection. There is no similarity between these two. Sebab kita tahu the complementary should be odd number. Even number cannot be odd number. Sama juga odd number cannot be even number. So kat sini kita kata this complementary event are mutually exclusive events. So these examples actually explain statement number 1. Complementary event are also mutually exclusive. Okay, statement number 2, they want to show that the other way is not necessarily. Dia kata mutually exclusive event are not necessarily complementary event. So the example that I can share with you, okay, for number 2, okay, let's say I do experiment, I toss a coin twice and I observe head and tail. So the sample space from the experiment is, okay, I ambil coin, saya baling 2 kali, saya nak observe. Okay, first trial, observe head tail. Second trial, I observe head tail. So these are the outcome. Four of them. In total, we have 4 outcome. Okay. So from here, I want to create event. Okay, my event representing both head. So what is the list of A in the set?
H, H.
H, H. Okay, now I want to create a mutually exclusive event with A. So now I create B so that they are mutually exclusive. Tak ada similarity. So kalau tak ada similarity, mudah je. Both tail. So can you list the outcome for B?
TT.
Okay, TT. So these A and B are mutually exclusive. Kenapa I kata dia mutually exclusive? Because there's no similarities, there's no intersection. HH tak ada karakteristik yang sama pun dengan TT. Okay, but what is your comment about the complementary event? Is A and B are complement to each other or not?
No.
No. Kenapa no? Apa maksud complement untuk A?
Pelengkap.
Pelengkap maksudnya selain daripada A, nak lengkapkan set. Kalau kita dah kata A, H, H, A bar should be T, T, H, T and TH. But this is not the complement of A. TT is not complement of A, tak cukup. Lagi dua tak ada kat sini. So B is not complement of A. Okay, sama juga B ni. Is A is a complement of B kalau kita ada event B. So what is the complement for B? So other than TT. So kita kena ambil HH, HT and TH. So tak ada dekat sini. So here even though it is mutually exclusive but
It's
Okay.
not complementary.
okay, mutually exclusive but not complement to each other. So this example actually explain statement number 2. Mutually exclusive event are not necessarily complementary event. But there are also case where mutually exclusive event can be mutually but not all case. Tapi kalau statement 1 ni for all case. Kalau dia dah complementary, confirm mutually exclusive. Yang bawah ni ada case yang boleh jadi, ada case yang tak jadi. Maksudnya tak jadi complementary. Okay. Okay, example 11. Alright, so this example, we want to see the concept or the idea of mutually exclusive in table. Okay, how do we read the table or how we take out the information from table? So this table summarize visitor to an amusement park. Okay, they divide this table into column and row. For the column, okay, in total, actually our experiment involved 3,600 visitor. Okay, it involved 3,600 visitor. So they divide them, the visitor. Okay, for the column, they divide them into visitor who purchase all day pass and visitor who purchase half day pass. Okay, that is one characteristic. Okay, instead of that, they also divide the visitor according to their gender. Okay, they divide them into male and female. So this is the figure. So 2,000 male, 1,600 female. Okay, yang ni untuk purchasing the pass or the tickets. 2,100 purchase all day pass, 1,500 purchase half day pass. But if we total column or row, all these two will add up to if you sum up all this, it will equals to 3,600. Okay, so now I want to create event from this sample space 3,600. Okay, event A, I choose visitor who purchase all day pass. So event A, visitor who purchase all day pass. Okay, event B, visitor who purchase half day pass. Okay, and I want to create another event which is event C. Event C, the visitor is female. Okay, 3 saja. Okay, yang male ni saya tak ambil lah dia punya tu. Kalau you nak create, boleh create D. Tapi for now, I just want to use A, B, C. Okay, from these 3 event A, B, C that you see from the table, can you tell me which of these 2 A, B, C, which of these 2 are considered as mutually exclusive event? Kat mana yang antara A, B, C ni, 2 daripada mereka yang kita groupkan sebagai mutually exclusive event?
AB.
AB, yes, you are right. Okay. So, is there any cases here where we can say that they are not mutually?
AC.
AC. Why? Why you say that AC cannot be mutually?
Because it is ada intersection, ada
Yeah.
similarity.
Yeah, there are similarities or intersection. So we have 900 visitors who at the same time female and purchase all day pass. So ni similarity dia. Okay. So what you share just now. Okay, what you share just now. Event A and B are mutually exclusive. Okay. Sekejap eh. Okay, semula. Okay, the event A and B are mutually exclusive. So betul. Okay, A and C are not mutually exclusive. Ada lagi satu sebenarnya. Gabungan antara dua tu not mutually exclusive. Yang mana satu? Which of this ABC? Tadi AC kan? Mana yang lagi satu not mutually exclusive?
BC.
BC. Because there is an intersection between female and half day pass. Okay. Okay. So the intersection A and C can be seen in the table above. Tadilah yang 900 tadi. You nampak dia punya intersection kan? Or we also can see them in Venn diagram. So how do we see the intersection in Venn diagram? I think everyone know how do we see intersection. So kalau kita ada dua A and C, intersection should be here. So the 900 tadi yang you nampak tadi tu mesti diletakkan dekat sini, yang kawasan yang saya lorekkan ni. So this is how we see the intersection between two events. So the reason why A and C are not mutually because there is a intersection. Okay, is everyone clear with this example?
Clear.
Okay, belum ada calculation lagi kan? Ni lebih kepada nak fahamkan konsep mutually exclusive dulu. Okay, now we want to see rule. Okay, in chapter 4, we have 4 rule. Okay, we have 4 rule lah. We have 2 rule. Okay, this is rule number 1. Okay, number 1, we have an addition rule in this subtopic. Okay, rule number 2, multiplication rule. So, multiplication rule, you will see that in 4.3. So, subtopik seterusnya dalam conditional event nanti. So, untuk yang sekarang ni, kita hanya guna, kita ada jumpa dulu addition rule. Okay, untuk for the rule, we put them into general and special. So kita start dengan general addition rule dulu, lepas ni baru kita pergi special. So there is the reason why from general it change to special. So asalnya dia general, tapi because of one reason. So reason dia apa nanti kita tengok. Because of that reason, general will change to special. Okay, so what is general addition rule? Let A and B to event define a sample space. Of course, we are going to use more than 2 event. Sebab sekarang ni kita dah start discuss tentang compound event. Okay, let A, B to event define in sample space. Then, if we want to find probability of A union B, okay, probability of A union B, sebab tu tadi saya nak you ingat balik macam mana kita nak how do we illustrate union in Venn diagram. So we want to find the probability of A union B. Okay, so A union B. So from the previous slide yang I tunjuk tadi union tadi, so you dah share, you kata kalau union, we should take the whole thing of the circle. Okay, A and B. Okay, then it become union. Okay, from here, if you want to find the probability of A union B, we should, okay, add all these two logic dia. So kita ambil dulu, kita kena tambahlah probability A tambah dengan probability B. That is the idea. Sebab tu you nampak ni. Sebab kita consider semua kan. So if I do this, okay, I lorekkan dulu. I take this probability of A. Okay. So probability of A plus probability of B, meaning I lorekkan ni pula. Okay. So now, you nampak tiba-tiba dekat belakang ni ada tolak minus intersection. Agak-agak kenapa berlaku What do you think? What is the reason that we have this part in our addition rule?
Sebab dia intersect 2 kali.
Sebab dia intersect 2 kali. Betul. Betul Nurin. Okay. Dia intersect 2 kali dekat sini. Tadi ada lorekkan sekali kan? Okay, ada lorek sekali. Okay, dah dapatlah PA. Okay, and then I lorekkan pula B untuk dapatkan PB. Sebab kita nak dapatkan union kan, union should consider all. But the problem is, kalau you notice, I lorekkan bahagian tengah-tengah ni 2 kali. So, bila I lorekkan 2 kali, dia jadi double dekat situ. So, bila double, kita tak nak lah. Kalau double maksudnya terlebih lah kita punya probability. So, that's why we have this minus one of the intersection. Janganlah minus 2 kali. Kalau you tolak 2 kali intersection, hilanglah pula, kosonglah pula tengah-tengah ni kan. So, you add all to PA plus PB. Then because of we see that the intersection become twice, so you remove one of that. Maksudnya you buang salah satu daripada intersection tu. So now we have the general addition rule. To get the probability of A union B equals to probability of A plus probability of B minus probability of intersection AB. Okay? Jelas? Kenapa kita ada formula ni?
Jelas.
Tadi Madam kata lepas general ada special kan? So here we have this special addition rule. Okay? Special addition rule. So macam mana daripada special? Kalau you tengok, masih benda yang sama. Okay, kalau addition rule kita nak cari probability of A union B. Sama juga yang tadi, general. So kat sini kita nak cari probability of A union B. Tapi formula dia, kalau you perasan, dia hanya ada PA plus BB. So when we can have this special, when we have this statement. If A and B, dia sama. A, B defined in sample space as if A and B are mutually exclusive. If A and B are mutually exclusive, then we have this one. Maknanya yang belakang tadi tu dah tak ada. So kita tahu kan kalau mutually exclusive, there's no intersection. Dia macam ni. A, B. So finding the union. So you will take probability of A plus probability of B. Do you see any intersection here or double intersection? Tak ada kan? So tak perlulah nak tolak apa-apa dekat belakang. Sebab tu dia kata if A and B are mutually exclusive then probability of A intersect B equals to 0. So tadi kan ada tolak ni kan, minus probability of A intersect B. So here we have minus 0. But for special addition rule tak perlulah nak tunjukkan minus 0 ni, kita dah tahu. Once we know that they are mutually exclusive, automatic we ignore the intersection part. Okay. Jelas tak bahagian ni?
Jelas.
Okay. So, Madam nak tanya lagi satu. Last week kan Madam ada tunjuk satu video kan and dia dah bagi tahu pasal probability zero. Sebenarnya apa yang berlaku kalau kita dapat probability zero tu? Bila you dapat apa-apa lah, tak kisah single event or compound event, if you calculate and you get exactly zero, what actually happen? What actually happen to the event? Probability zero.
Impossible.
Impossible to happen. Meaning that particular intersection, sekarang ni kan, probability of A to be intersect with B is zero, meaning this intersection never happen in mutually exclusive. Okay, sebab tu dia kata dekat sini probability if A and B are mutually exclusive, then the probability of A intersect B equals to 0. Equal to 0 meaning intersection will never happen. Impossible to happen. So tadi 0 ni boleh letak kat belakang. Okay. Okay, special addition rule can be extend to more than 2 mutually exclusive event. We only can extend special addition rule, not for general. Okay, bukan bermaksud kita tak boleh cari langsung addition rule untuk general. Kalau kita ada lebih daripada 2 event boleh cari, tapi kita tak discuss untuk ataupun we don't include that part in our syllabus. Okay, sebab apa? Sebab formula dia lebih panjang. Dan lebih complicated lah untuk kira addition rule involving more than 2 event. Okay, but then kalau dia special, kalau it involve many event and all of them are mutually exclusive, so based on our understanding, kalau dia mutually exclusive, so kita akan ada yang tak ada yang bertindih kan? So there's no intersection between them. So if we want to find the union of all this, so ni. So there's no similarity, no redundant. Tak ada pun yang bertindan ke apa ke, bertindih semua. Okay, bersilang semua tak ada. So bila kita nak cari probability of A, union B, union C, union D, union E, this is actually addition of all the probability here. Probability A plus probability B plus probability C plus probability D plus probability E. This only can be done under special addition rule, not for general addition rule. Kalau general addition rule, just for 2 event untuk level kita yang belajar sekarang. Okay, nanti kalau you pergi higher level, you akan tengok formula general addition rule which involve more than 2 variables. Okay. Setakat ni ada nak tanya? Okay. If no question, so now I want to show you example 12. Okay. All employees at a certain company are classified as only one of the following. So they want to say that the sample space of this study, the sample space consisting, sample space ni dia punya we consider all employee and that company. So all employee ada yang jadi manager, which is A, ada yang involved dengan services, which is B, ada yang involved dengan sales, which is event C, ada yang involved dengan ataupun ada yang jadi staff biasa. Okay, kerja-kerja pentadbiran. Okay, so here this is D. Okay, so if we combine all A, B, C, D, so it becomes the space of this study. And you should take note that it shouldn't be similarities between them. It shouldn't be intersection between them. Sebab apa? Sebab manager cannot be service. Service cannot be staff. Sales cannot be manager. Okay, in this case, they are mutually exclusive to each other. Okay, itu lagi satu maklumat yang tidak dinyatakan dalam soalan tapi kita kena tahu. Okay. So now I nak okay, it is known that so they give all probability of each outcome. So dia bagi ni probability A, B, C and D. Ni this one is given in the question. Okay, now let's recall back last week punya content yang kita belajar. Okay, I show you properties of probability. There are 2 properties. So now I want to recap on the second properties. So let's say now I want to find this. From the properties, what we should write here? This is equals to what? Daripada property, bukan you kira Bukan you kira, daripada property. Kalau kita tambah semua probability outcome, sepatutnya kena dapat berapa?
1.
It should be equals to 1. So kalau you check, you try to add up all this, it should be equals to 1. So this is property number 2, properties of probability. Okay, the summation of all outcome in the sample space should be equals to 1. Okay, so now we want to answer all this, A, B, C, D. Okay, I'll go one by one. Okay, what do you understand about question A? Probability of A bar ataupun probability of complement of A. A just now is a manager. So what is the probability of A complement? Dia nak cari probability apa sebenarnya? Selain pada manager. So how do we find other than manager? What should I write on the next line? Ataupun what should I write with this? Maksudnya, okay. Formula apa yang kita nak guna kat sini?
1 minus PA.
Okay, 1 minus PA. Yes, you are right. Okay, 1 minus PA equals to, okay, PA is given. So, just calculate and this is the answer. Ataupun you boleh tambah ni, PB plus PC plus PD. So, you will get the same answer. Okay, that is a complementary question. Okay. Probability of A intersect B. What will be the answer for part B?
Zero.
Okay, why you say 0?
Sebab ni sebab ni mutually exclusive.
Betul. Since A, B, C, D are mutually exclusive, so A, B are mutually exclusive lah. Okay, A, B mutually exclusive, we know that if A, B are mutually exclusive, meaning there's no intersection. So no intersection meaning the intersection never happened. So if the intersection never happened, probability should be equals to 0. Okay, probability should be equal to 0. Reason dia A, B are mutually exclusive. Okay, thank you for your response. Right. Okay, C, probability of B union C. How do we find this one?
PB tambah PC.
PB tambah PC. So you guna addition rule. Is it general or special?
Special.
Why special? Kenapa tak guna general?
Mutually exclusive.
Sebab tadi kita dah tahu kan A, B, C, D are mutually exclusive. So you straight away apply special addition rule. Okay. So PB plus PC equals to 0.65. Okay, very good. Okay, D. So now we expand union A, union B, union C. Dia lebih kurang macam soalan C tapi dia ada lebih event dia. Union dia tu lebih.
0.8
0.8. So how you get that?
PA plus PB plus PC.
Okay, yes, you are right. Okay, why we can add all these three? Because they are mutually exclusive. So remember just now, special addition rule can be expand to more than 2 events. So kalau dia ada lebih daripada 2 event, you bolehlah guna formula PA plus PB plus PC. Only for special, not for general. So kalau general, contohnya macam case ni not mutually exclusive. If let's say A, B, C, D are not mutually exclusive, we have problem in solving this. Sebab kita tak belajar formula tu. Kita tak ada formula tu sekarang. Ada formulanya but we don't include it in your syllabus. Okay, but since this is mutually exclusive, so tak ada masalah lah. Terus boleh guna special addition rule. Okay, setakat ni ada soalan? Jawapan ni. Okay, one more example. A consumer is selected at random. The probability that the consumer tries snack food is 0.5. Try new soft drink is 0.6. Try both the snack food and the soft drink is 0.2. So dia bagi dalam bentuk ayat. Dia kata probability try snack food. Okay, consumer ni probability dia try snack food is F. And the value is 0.5. So kalau I tulis dalam symbol, probability of trying snack food which is F, event dia F, is 0.5. Okay, and then yang purple ni, probability try new soft drink. Probability try soft drink is D, equals to 0.6. Okay, what is try both snack food and the soft drink? What is this actually? The probability equals to 0.2. So ni compound. Kan dia gabung dua-dua, food dengan soft drink. So how do we write it in probability? It is a probability of what sebenarnya?
F union D.
Is it union?
Intersect.
Intersect. And is intersection. Union should be OR. Okay, so this is F intersect D, which is equals to 0.2. So we need to take out these 3 information. So we'll use this in the question A, B, C, D. Okay, kita akan ambil 3 maklumat ni, PF, PD and PF intersect D. Okay. So ni tadi I dah keluarkan. Okay, now I want to answer part A. Probability the consumer try snack food or the soft drink. So So the keyword is here. Try snack food or the soft drink. Dalam soalan tadi dia kata try snack food and the soft drink. So yang ni. So sekarang soalan tanya probability try snack food or the soft drink. So kita nak cari probability apa ni? Guna simbol FD.
Union.
So union. So meaning we want to find probability F union D. Probability F union D. Okay, what should be the next line? Nak guna apa? Nak cari F union D ni?
General.
General addition rule. So kita tak boleh guna special. Sebab apa? Sebab they do not mention about mutually exclusive, and you nampak there is a intersection kan? Bila ada intersection, it's confirmed that the event are not mutually exclusive. So you must use general addition rule. Okay, we have all the information, PF, PD and PF intersect D. So substitute all the values here and calculate, the answer will be 0.9. Okay, yang paling penting you kena tackle soalan tu dia nak apa. Lepas tu baru kita fikir nak guna formula yang mana. Ni kalau dah salah pilih, sepatutnya union you pergi buat intersection. Bawah-bawah ni semua pun salah. So yang penting line pertama ni. Okay, F union D. Okay. B, not tried snack food. Okay, keyword dia not. Yang ni hanya satu event. Snack food. F saja, tapi ada not try snack food. So I kata kalau ada event yang dia masukkan perkataan not, maksud dia apa?
Complementary.
Complementary. So we want to find PF bar. Complementary of snack food is F bar. So how do you find F bar just now? Ataupun apa-apa saja complementary, formula apa kita akan guna? So what will be the next line?
One minus PF.
Yes, 1 minus PF. So 1 minus 0.5 is 0.5. Okay. Right, this is B. Okay, C. Try neither snack food nor the soft drink. Okay, so the keyword is here, no. Okay, ataupun ni opposite for or. Opposite for or. So dia gabungan not dengan or. No ni gabungan not dengan or. So try neither snack food nor the soft drink. So what is this actually?
FUD prime.
FUD prime. So you akan ambil you punya union. Everything is prime. F prime. FUD, apa saya sebut? Prime. Bar.
Bar.
Bar. Saya pun ikut sekali prime. Okay, FUD bar. Okay. So ni combine union and bar. Okay, union and bar. Okay. So macam nak cari ni? F union D tadi dah dapat I rasa dekat soalan A. Kan soalan A dia cari F union D. So once you have F union D, to find the complement of F union D, sama je konsep dia, you akan ambil 1 minus probability F union D. Okay. We get this from part A, which is 0.9. So calculate, the answer is 0.1. Okay, this is C. And lastly, we have D for this example. Okay, try only the soft drink. Okay, the keyword here is only. Only soft drink. So to see this event clearly, okay, let's say I have this Venn diagram showing. Okay, I have snack food and soft drink. Okay, width of this region show that they try only soft drink. So minggu lepas pun ada sebut pasal only ni. Kalau dalam Venn diagram, kat mana nak tengok try only soft drink?
Di luar bulatan tengah tu tapi bahagian D.
Okay, di luar bulatan tengah tapi bahagian D. Yang bulan sabit ni kan? Okay, yes, you are right. Okay, we want to find this probability. So how do we get this region from the information given here? Macam mana nak dapatkan kawasan berlorek ni daripada maklumat-maklumat yang ada? Kita nak ambil mana, tolak mana atau ambil mana, tambah mana? Mana yang bersesuaian? Hint dia, maklumat-maklumat yang diperlukan semua ada kat atas ni. Pilih mana yang bersesuaian.
Zero point
Okay, 0.6
tolak 0.2.
Okay, meaning probability of D, so you ambil the whole thing D. Okay, because of you don't want the intersection part, then you will remove the intersection part. So you akan ambil probability of D minus probability of F intersect D. So yang you kata tadi 0.6 minus 0.2. Yes, you are right. So this is probability of D minus probability of F intersect D. Okay, substitute the values and calculate. The answer is 0.4. Okay. Kadang-kadang kalau you tak nampak soalan tu, nak buat macam mana, lukis Venn diagram. So bila kita lukis Venn diagram, mungkin daripada Venn diagram tu baru kita nampak nak ambil yang mana, nak tolak yang mana, nak buang yang mana, nak tambah yang mana. So Venn diagram lebih jelas. Okay. Setakat ni ada soalan? If no question, so let's go and try this exercise quickly, okay, before we break. Okay, 3 questions from page 10 in your module. Okay, page 10 in your module. Question 3, 6 and 13. So these 3 questions not only for today's lecture, it also involve a last week lecture. Okay, complementary event, probability of single event. So kita nak cuba jawab soalan-soalan tu. Termasuklah hari ni lah munculi eksklusif. Okay. So we start with number 3. Okay, 3 identical slip of paper with the number of 1, 2, 3 are placed in a box. So let's say I have a box. Okay, inside the box I have 3 paper numbering 1, 2, 3. 1, 2, 3. So this experiment, one slip is randomly selected. So I ambil satu slip and then without replacement, a second slip is selected. So ada 2 trial. I take the first slip and then I repeat, I take a second slip without replacement. Without replacement maksudnya, contoh you dah ambil slip nombor 1, you tak letak balik slip tu dalam kotak. So you ambil nombor 1, you ambil nombor 2 pula. Ataupun you ambil nombor 2, lepas tu you ambil nombor 3. There's no possibility you dapat nombor 2 because without replacement. So if you want to see the sample space, we could use a tree diagram. So for the first trial, I have 1, 2, 3. Second trial, if I already choose 1, only remain 2 and 3. So if I take I take number 2 for the first trial, so this one become 1, 3. Okay, for this it become 1, 2. So from the tree diagram, if I try to list all the sample space, so I got 1, 2, 1, 3, 2, 1, 2, 3, 3, 1, 3, 2. How many of them? What should be the number of sample space?
Six.
6. Okay, you will count the ordered pair. 1, 2, 3, 4, 5, 6. Okay, the question is, find the probability that the sum of the 2 numbers is even. So now I create, sum of the 2 numbers is even number, nombor genap. Okay, now I create event. Okay, maksudnya saya create event. So let's say this is event A. Sum of 2 numbers is even number. So the sum should be, hasil tambah 2 nombor tu should be 2, 4, 6, 8, mesti dalam nombor genap. Okay. From the sample space, can you list the outcome for event A? where have some of the numbers is
1, 3.
1, 3.
1, 3,
3, 1.
3, 1. Okay. What will be the number of A?
2.
2. Okay. So the question asks, find the probability of the event. Probability of what? Probability of sum of the two numbers, which is probability of A. I represent the event using capital letter A. So probability of A equals to, using formula, number of A divided by number of S. This is equals to 2/6 or 1/3. Okay. So in this question, you should start with finding the number of sample space first. If you are not sure, you can use tree diagram. So from the tree diagram, you list all the outcome, then you count them. You count them, kira ada berapa. Okay, lepas tu baru you start dengan event. Okay, bila nak cari probability, biasanya memang you kena start dengan sample space dulu. Sample space of that experiment. Okay, ada apa-apa nak tanya soalan nombor 3?
No.
Okay. So next question, question 6. 5 cards are randomly selected from a standard deck. Let A be the event that all 5 selected cards are the same suit. Using counting technique, the probability of A, probability of 5 selected cards of the same suit can be computed to be 0.002. Maksudnya probability all the cards are the same suit is 0.002. Okay, so kat sini dia kata event A tadi, event A is all 5 cards are same suit. Okay, so eksperimen ni sebenarnya, they want to pick 5 card from a standard deck. Kalau mungkin you pernah tengok card yang ada diamond yang biasanya orang main down trope tu, okay, biasanya orang buat dalam kalau dia gambling, kan? So dia akan guna kad tu. Ataupun dia nak lawan ke, main-main ke. So dia akan guna kad. Dia pun tak berapa sure sangat macam mana kita nak baca suit tu apa semua tu. Tapi what I know is, dekat dalam kad tu dia ada group-group dia. Okay, they call here suit. So the 5 card they choose from that set of card is from the same suit. Daripada kategori yang sama. Okay, so probability of getting that same category is given by this. Probability of A is 0.002. Okay, ini information yang kita yang diberilah dalam soalan. Now, find the probability that all the card are not the same suit. So keyword dia dekat sini, not. So dia sekarang dia create event. All the card are not the same suit. So sebenarnya event ni refer kepada event apa? All the A bar. This is actually statement merah ni complement of A. This is actually a complement of A. So the question want to ask about probability of A bar. So everyone know this. Finding probability of A bar equals to probability of A. 1 minus probability of A. So 1 minus 0.002. So try calculate what you should get here. Very simple calculation. It should be
998.
998. Okay. Question number 6 is a question related with complementary event. So bila you nampak je perkataan not tu semua tu, mesti ada kena mengena dengan complementary. Bila dia start je guna not apalah, tak kisahlah apa benda karakteristik dia kan. So mesti ada kena mengena dengan complementary event. Okay. Last question before we have break. Okay, question 13. Explain why events A and B cannot be mutually exclusive. Ni yang kita belajar hari ni lah. Okay, explain why event A and B cannot be mutually exclusive if they are defined on a common sample space with PA. So PA equals to 0.56. Okay, PB 0.61. This is given. And dia kata, kenapa A and B is not mutually exclusive? Why? So, explain dekat sini bukan bermaksud you kena bagi jawapan dalam bentuk karangan panjang-panjang explain, ayat bunga-bunga, tak. Okay, explain yang dimasukkan dekat sini, you kena guna, you kena explain using calculation, using numbers, using formula, using rule, which is suitable to this idea of mutually exclusive. Okay, so anyone can share with me what actually we can apply here, okay, to explain why A and B cannot be mutually exclusive. Agak-agak kita nak guna teori ataupun rule ataupun formula ataupun persamaan, yang mana satu? So that we can show that A and B cannot be mutually exclusive. A and B ni sebenarnya A and B are not mutually exclusive. So dia ada intersection sebenarnya. There is an intersection between A and B. In another word, we should explain why A and B has intersection. Kenapa? Daripada nombor yang dia bagi ni. So what we can do? You tak boleh cakap, okay, because they has intersection. So how you know they has intersection? Mesti ada satu nombor ataupun nilai yang menunjukkan ada intersection tu. So how do we show that? Macam mana nak buat? Nak guna apa? Do you see any rule for mutually exclusive previously? Rule mana yang you jumpa mutually exclusive punya idea? Rule, R-U-L-E, rule.
They are not complement to each other.
Not complement to each other?
Special addition rule.
This one better. Okay, complement to each other, there's nothing to do with complementary idea here. Okay, there's nothing to do with complementary idea here. Sebab kalau complementary dia macam ni you ambil statement tadi kan, dia kata cannot be mutually exclusive tu, they are not complementary. Mana tak nampak lah complement punya idea kat sini. Okay, tak apa, mungkin lepas ni kita tengok sesuai ke tak. Tapi yang Haris punya idea tadi tu, we apply special addition rule lebih tepat, lebih direct. Okay, special addition rule kita tahu, special addition rule if A and B are mutually exclusive. So we start with this. If A and B are mutually exclusive. If A and B are mutually exclusive, then we apply special addition rule, which is A union B equals to probability of A plus probability of B. So please calculate for me the value of this addition.
1.17.
1.17. Okay, so now you continue from here. What we can explain actually. Sambung, tak habis lagi ni. Ni kita kata if A and B are mutually exclusive, we can apply special addition rule. Okay, saya dah buat dah apa yang Haris suggest tadi. Okay, then lepas tu nak explain apa lagi?
The value is more than 1.
The value is more than 1. Okay, betul. But what do you mean? What is the issue if we have value more than 1? What is the issue here? Ni last week punya lecture. Property. Property of probability. Property number 1. Terus bagi jawapan dah.
The sum of all probability should be 1.
That is property number 2. Property number 1. What number 1 says? Probability must be between whatever
0
probability.
and 1.
Yeah, 0 and 1. Whatever probability, doesn't matter is a single event or compound event, union or intersection. If it's a probability, it should be between 0 and 1. So now, this value do not follow the properties. It's greater than 1. It's beyond the range. Okay, so kalau kita kata if A and B are mutually exclusive, this is not true. This is not true. Kalau dia mutually exclusive, nilai kat sini tak boleh lebih pada 1. So something wrong here. Kenapa lebih? Sebab lebih, kan ada intersection? Yang lebih tadi tu, kan ada intersection? Sepatutnya kita tak boleh guna special addition rule. Kita kena guna general addition rule. Okay, general addition rule. Okay, so here, kita tulis balik. So, A and B cannot be mutually exclusive. Okay, awal-awal ni kita kata kalau dia mutually exclusive, this special addition rule should work. But here it doesn't work. Probability more than 1. So what is the issue? Probability cannot more than 1. Okay, probability must be between 0 and 1. So our statement here is not true. Statement yang kita bagi ni, counter statement yang kita bagi ni salah. So kita betulkan balik statement kita, A and B cannot be mutually exclusive. Okay, clear? Jelas tak?
Jelas.
Alright, so after this we'll continue with subtopic 4.3, conditional probability. But then kita rehat sekejap, 5 minutes dan kita sambung Okay, siapa yang belum tanda attendance, please go to Putra Blast and take attendance. Lepas break nanti, madam check. Okay, thank you.